All right, good morning, everyone. Hope you all are having a good day today. So we're going to be going over Chapter 14 today. Chapter 14 is all about controlling and monitoring access. So it's a pretty short chapter, actually. There's about 2 sections in it. Technically 3, but one of them we already covered. So it's all about comparing access control methods, as well as also understanding access control alerts. All right, so just a brief little review to get us back in the mindset of thinking about this. We talked last class about identification. Who can tell me what identification is? So if I said, your name is Patrick, that's your identification, right? Okay. I hope I got your name right. I'm pretty sure I did. Okay. That'd be embarrassing if I didn't, though. Okay. Authentication. What's authentication? Okay. It's verifying that you are who you say you are. We can do it a lot of different ways. Okay. If I were to go up to Patrick and I said, Patrick, show me your driver's license. That's authenticating that he's in fact Patrick. All right. If you're on a system, like Haley said, use a password. Okay. What are some other authentication factors we may use? Make sure the audio is on. We could use a physical token, sure. What else? Biometrics, okay? Think of one more. Like a authenticating app or RSA key, something like that. Okay, so in this class today, we're talking about authorization. Okay, we've already authenticated. Now we're granting the access. So that's all we're talking about today. And there's a couple things in the book that it says that are different. Okay, and I agree, definitionally, there's some slight differences. However, practically, when you go off into a workplace, you don't want to be that guy or that girl, I guess, who sits there and argues about the difference between permissions and rights. Okay, because if you do that, that's not a cool thing to do. All right, do you want to be not cool? No, you don't. Okay, so understand it for the certification. I think it's a ridiculous distinction, though. Does that make sense? Does everyone understand? Okay. So permissions. These typically deal with files. What you're allowed to do to the file. Can you read it? Okay. And of course, by read, we mean can you access it and open it? That's, of course, what we're referring to. Can you write to it? You know, that's certainly an important thing to be able to do in some circumstances. Okay, so imagine you're working for an employer and your job is to, let's say your job is to be a network administrator. What do you think you may need write access to? Pretty much any firewall, right? Pretty much any network device, period. Okay? When we talk about write access, obviously we're talking about the system configuration of it. Okay, because that's a file, is it not? Okay, you push a configuration file to an access point. Then you adopt it. Pretty straightforward stuff. Talked about that a lot last semester. Okay, let's say that you're an accountant. Okay, Ron, you're an accountant, right? You get an IT audit job, though, right? At an accounting firm. So we'll pretend you're an accountant. Okay, so Ron is an accountant. Okay, Ron needs to have not only read access to people's tax returns, but write access to people's tax returns. Okay? Does that make sense? Now, does he need to have read and write to everyone's? Is this a standard accountant? Probably not. Okay, because he has a list of clients, does he not? Does it make sense for him to have write access to someone else's client? Okay? So rights, in contrast, are not necessarily codified in a traditional sense where you have a file with certain permissions. Okay, this is more talking about what you're allowed to do. So if you're working for a company Do you have administrative rights on the computer? Okay, I don't know that answer. All right, maybe you do, maybe you don't. The book talks about, do you have the right to restore a backup? That's a right. Okay? And then finally you have privileges. Okay? So privileges are basically just overall what access do you have. So it's taking a look at both permissions and rights. Now again, when you go off into the workforce, do you want to argue with everyone about the definitions of these? No, you don't. All right? These are going to be used interchangeably. And there are differences, but don't be a loser. Does that make sense? Let's talk about how permissions actually work. Okay? So, if you're using a Linux-based operating system, here's how it goes. Okay? So there's three groups. Okay, you have the file owner, and you have the group, and then you have the others. Okay? And basically, you can modify the permissions using the change modification, which of course we refer to as chmod. Okay, if you want to change the owner of the file, for instance, what are you going to use? Okay, change owner, which of course we shorten to chown, chown. All right, basic Linux stuff you've probably already come across. Okay, so the XXX refers to whatever access you're going to be granting. Okay, and this works in binary. Okay, so the first is 0 or 1 for whether or not they have execution privileges. Okay, that's going to be a 0 or a 1. Okay, the second is still a 0 or a 1, and it's for write. Okay, and then the third, of course, is for read. And that's, anyone want to take a guess? 0 or 1, exactly right. Okay, now, in binary, obviously we know that the first is going to be a 1. Okay, and we go to the second. Okay, what's that going to be? It's going to be a 2. Okay, and then the third place is going to be a what? Exactly. Okay, so we denote this by adding up what access they have. Okay, so let's say that we want to give the owner, we want to give them read, write, and execute. We want to give the group read and write, and we want to give others just execute. Or not just execute, that'd be stupid. We want to give them just read. Okay? So how we do that? Of course, the first owner is going to be, they're going to have execute, so that's 1 plus 2 plus 4. What's that equal? Okay, 7. That's right. Group. We don't want to give them execute, but we want to give them read and write. What's that going to be? 6. Okay, and then finally for others, we just want to give them read. What's that going to be? 4. Okay? So you would use sudo chmod 764, and then wherever the file is located. That's all you have to do. Okay, does everyone understand sudo? All right. So sudo, of course, is basically the equivalent in Linux and Unix systems of running things as administrator. Okay, a lot more to it than that, but this is not a Linux class, this is a security class. So does everyone understand this? Is anyone confused? All right, here's a question. Who wants to walk me through if I wanted to give all three groups? So I want to give the owner, the group, and the others. I want to give them read access only. What would that be? Someone tell me. 444, exactly right. And how'd you get that? Yeah, so they're going to have a 4 for read, and they're going to have a 0 for write, and a 0 for execute. So 4 plus 0 is, of course, our good friend 4. Okay? So it'll just be sudo chmod 444, then file path. All right, questions? Yeah. What do you mean? Well, yeah, if you're giving everyone read access only. Well, this is why it's a 4, okay? Because the first position is execution, so that's going to be a 0 or 1. And it's in the first decimal place in binary, which is, of course, going to add to 1, okay? Same thing with write. Write's the second one. It's still either 0 or 1, but because it's in the second decimal place, it's going to be 2, because you'd have to go 1 over, basically. And then with read, it's the same thing we did last semester with, like, hex conversion and that sort of stuff, and, like, converting from binary to decimal. Any other questions? All right, don't forget this. Like I said, I think this is something's not really covered in the book, but I think that you should know it, okay? Because let's face it, 70% of servers run some variation of what? Don't say Windows Server. Linux, all right? So chances are good, if you ever become a sysadmin, you're going to be dealing with which type of system? Linux. That's why you need to know this. All right, Windows permissions, all right? Make of this hand what you will, okay? But let's take a look at them together, okay? So I'm just going to pull up a random file. And it's a lot more complicated with Windows than it is with anything Unix or Linux based. So let's just take a look at a random file. All right, so I'm just going to right click on it, go to properties. Okay, and we can see where it's located, the size, that sort of stuff. Go over to security, we can edit permissions. All right, so I can decide what the system has, what I, the user, has, and what the group of administrators have. Because if I wanted to, I could deny myself the ability to modify and edit this file. Why might that not be a good idea? Okay, because it's my file. You know, I want to be able to edit it down the road, right? But you could certainly change stuff if you were so inclined, okay? So, to me, it's a lot easier to use stuff like chmod, but maybe you feel Windows is easier. I'm not here to tell you which operating system to use. I don't really care, okay? But that's all you're doing there. Any questions? Okay, let's talk about authorization. Some different techniques and stuff to think about. So there's a bunch of different policies up here, and I'm going to go through them all. So take notes if you need to. Okay, the implicit deny, it's going to be where unless there's a rule approving something, it's denied. Okay, and last semester, what do you think we might have had an implicit deny rule on? Okay, if we were to play Hangman, what would we put? Someone pick a letter. Okay. Okay. Firewall. Probably going to put an implicit deny rule to where if we don't have a rule approving it, it gets rejected. Okay, so an access control matrix. It's basically where you have a matrix. Okay, so a matrix, of course, being you have stuff on the X and the Y. Okay, and you may have permissions / systems that people can access, and then you may have groups up here. Or you may have individual users. Groups probably makes more sense for most things, but it's just a matrix. So you have a system, someone throw me their favorite system. Literally any system. Okay, so we'll say we have a TPS system, and we say who can access it and which permissions they have. Okay? That's all an access control matrix is. Constrained interface. Okay, that's where you have different views depending on what your role is in the organization. So for instance, If you're in my database class, which is an example of a constrained interface? So specifically, what's something that we've created that you can assign to users, basically? Well, not exactly. So you could say a view or a window, right? Okay, those are examples of constrained interfaces. You've assigned specific things that people can view, and you can assign that to different groups, okay, or different users. Context-dependent control. This is something that's going to be a little bit less common, where basically you have different things you can see depending upon what has been done. So the example from the book is you're not going to get to the checkout page unless you've entered payment information and shipping information. I don't think that's the best example of it, but hey, whatever. Okay? Need to know is where you only can access what you need to know for your position, basically. Least privilege, basically the same as need to know, where basically you have the least amount of access that you could possibly have. Okay, so let's say we're an organization, all right? And let's say that we are a retail store. Okay, you guys familiar with retail? Least privilege. What would that look like for a cashier? Okay, so they can input new transactions. Can they avoid existing transactions? Probably not. They probably have to go to customer service to do that, or probably have a manager do that. It's least privilege, least amount of things they have to do. Now, why do they need to be able to input new transactions as a cashier? That's their job, exactly right. Okay, this is not very difficult stuff here. Okay, and then finally, you got separation of duties and responsibilities. All right, and basically all this is saying is you got to have at least two people do sensitive stuff. So think back to what are those locks called where you have to have two keys to open them? You guys know what I'm talking about at least? They have them at banks. They had them in like the Cold War stuff. Separation of duties and responsibilities. Okay? Think about the two locks. Now, is that a very efficient way to do things? Why is it not efficient? Yeah, so you're having to have two people tied up at minimum instead of one. What are the benefits? Could be more secure. Could it prevent rash decisions? Potentially. Maybe. All right. So let's say you're at a company. Okay, and you're tasked with writing a security policy. Okay, what are you going to start with? What's more important than anything else in security? Maybe people, but more important than people. Okay, what the organization needs. Okay, because let's face it, if you say we're just not going to allow our company to do anything, is that secure? If you say we're just going to leave an implicit deny rule and have absolutely nothing approved past the firewall, that's secure, is it not? It's not going to have any data breaches. Doesn't meet the organization's needs, though. Okay. Organizations need what? What do they need? Okay, revenue is exactly right. Okay? So if you prevent your organization from gaining revenue, you're not doing a good job. Let's just be blunt. Okay? Now, what do they need to survive? Arguably more important than revenue, although I think you're splitting hairs if you're comparing these two things. Profit is exactly right. Okay? That's good. I'm glad to see that our upper level business students understand business. Okay? That's vital. In fact, that's probably more important than anything in here. But second to that, we have the CIA triad. Because let's face it, if we have a data breach every 2 seconds, okay, we're not going to be profitable, are we? We may have revenue, not for very long likely, but we may have revenue. But the CIA triad helps prevent expenses from occurring. So it's a preventative thing, okay? It's like most of you probably wear a seatbelt. I would hope that all of you wear a seatbelt, but most of you probably do, all right? I'm not going to ask you if you don't wear a seatbelt, but you should consider wearing one. It's a good measure, okay? Why do we wear seatbelts? Does it make us a better driver? Are they fun to wear? It's because they're cool. Why do you wear a seatbelt? So you want to prevent injury, right? It doesn't make you less likely to get in an accident. Okay? Same thing with CIA triad, although hopefully it does make us less likely to experience data loss. All right? And then lastly, once you've considered the CIA triad, make sure that it's a very generalizable policy, but also specific where it needs to be specific. So, for instance, your security policy, how often do you think that's going to be updated? 3 to 5 years, maybe? How often do you think technology changes? More frequently than 3 to 5 years? Probably so. So instead of saying we want to ensure that we're on version 64.2, you would say we want to ensure that we're on the latest version that addresses known vulnerabilities. Why is that preferable? Yeah, so if technology changes, you don't want to constantly update a security policy. Because let's face it, most organizations larger than, say, 50 employees, are policies just signed off by one person? No, signed off by quite a few people. That could be a slow process. All right, so make it generalizable, yet specific. Does that make sense? A little bit complicated. Let's go over some various access control methods. Okay, so you've got discretionary access control. And you guys remember when I showed you the permissions in Windows? That's discretionary access control. Okay, it's one of the guiding principles behind Microsoft's NTFS file system. Well, that's a little bit redundant because the FS stands for file system, but you get the idea. Okay, so who is able to determine the permissions on anything in NTFS? It's always the owner. All right, so role-based access control is where we determine who can access what based on their role or position. All right, and that's probably what you're going to run into for most security policies, because it's something that's pretty easy to deploy. It's really easy to do with Active Directory. You just assign roles that are probably going to be done automatically at a larger company anyway. And yeah, really straightforward. Okay. Rule-based access control is just a little bit different than role-based. Okay, so with rule-based, what you're doing is you're basically establishing rules for what would constitute whether or not any individual can access something. So why would that not be applied at most organizations? Because how on earth do you manage that with more than a handful of employees? It's quite cumbersome, is it not? So you have a big set of rules, and you're basing every decision off of it. Okay? Why make things more bureaucratic than they have to be? Is there a good reason? No. All right, you got attribute access, or attribute-based access control. Okay, and this is where it's going to be more dependent upon patterns of some sort. So last semester, we talked about software-defined networking. And this is something that a lot of companies are moving toward, where instead of having a lot of more traditional like physical controllers. Okay, they use software-defined networking. Okay, you'll commonly see this as SDN. Okay, and this is beneficial for a cost and management perspective in some cases. Okay, don't assume that it's always going to be the way to go because it won't. Okay, but think back to last semester. We talked a lot more about software-defined networking. Same thing with deep packet inspection. Okay, it's not a rule. Okay, so when we talk about deep packet inspection, what we're doing is we're looking at each individual packet and we're seeing what it really is. Okay, because let's face it, you can say you're using port 443 and you can say you're an HTTPS protocol. Can you not? Does that mean you are? No, so deep packet inspection is actually looking at the individual contents. All right, a couple more. Mandatory access control. It's going to be used a lot in the government. Okay, so what you're having here, you're having strict classifications of both the subject and the object. Now, last class we talked about subject and object. Ben, what's a subject in the context of IS? It's who's accessing it, right? All right. Patrick, what's an object? Well, it could be a file, but more specifically, it's what's being accessed, right? Okay, and the reason I make that distinction is because an object can be another person, all right? It can be a lot of things. It doesn't have to be a file. That's why I make that distinction. You're right in most cases, though. Okay, so one example of this is the government has their classification where they classify some things as top secret, some things as secret, some things as sensitive, I think is the term, and then some things as unclassified. So if something's top secret, who can access it? People with top secret clearance, exactly right. Okay, so that's mandatory access control. All right, then finally, you got risk-based access control. This is another one that may sound good on paper until you think about it for 2 seconds, okay? Because basically what you're doing is for every single thing, you're performing a risk assessment. You guys remember we did risk assessments earlier in the semester, I think chapter 3? Imagine doing that for every single file. That would be quite cumbersome, right? So of these, what do you think is the most likely that a company may use? Probably role-based access control. I'd agree there, Ron. Okay, let's go over some different access control attacks. So most of these are either going to be password-based or privilege-based, okay? So privilege-based, all you're doing is you're gaining access to privileges you shouldn't have, okay? So you can do this horizontally, where you access a bunch of different user accounts with basically the same types of permissions, but maybe slightly different files they can access. Or you can do it vertically. Okay, so if you're accessing this vertically, what you're doing is you're trying to get administrative type account that can access a lot of stuff. Okay, so one example of mitigating this that CISSP suggests is to minimize the use of sudo. Now, that's pretty confusing by itself because you cannot be an administrator without using sudo, right? Think back to last semester when we were in the lab, okay? You guys didn't have sudo access, did you? All right. What happened when you tried to run something that needed escalation? Okay, I had to do it. That's best practice, is it not? Okay, that is in fact best practice. All right. So with that in mind, you have to balance that though. Okay, because imagine you have 10,000 employees, and let's say you have, I don't know, 250 IT staff. Okay, and not all the IT staff are going to have sudo access either. So you don't want to be running around all the time. Is that fair to say? So obviously in that context, you could of course apply different privileges based on what's actually needed. Okay, so that's one example there. I think my battery's dying. But you also have password attacks. Okay, so as the name password attacks would imply, it's attacks where you basically gain a password. So the first can be a dictionary attack. Okay, so what's inside of a dictionary? Not a trick question. What do you do in a dictionary? You look at words, right? Okay, so a dictionary attack most of the time is going to have a bunch of words, but it can also have common passwords as well. Okay, in contrast, a brute force attack is going to be where you're basically trying every possible combination. Okay, now most of the time, those aren't going to be enough. Now, dictionary will probably, if you run it against enough accounts, you're going to get in easily 2 out of 3 times. Okay, is that fair to say? Because these dictionaries, they don't stick to cat, dog, mouse. All right, they go a lot more in depth with common passwords. But if you had a particular account you want to access, hopefully none of you use a common password. All right, so hopefully you're not using password 123. All right, for instance. So hybrid attacks where you use both dictionary and brute force to access a specific account. Okay, spraying attack, that's going to be where you have several accounts you're trying to access, possibly even across different services. And this doesn't really work in modern time, but what you would do is you'd sort of do like a round robin thing where you go around and you continually guess different password and username combinations. That way you're not getting locked out of the system. But in modern day, you're going to get locked out of the system if you do that. Does that make sense? Now, you would pretty much do dictionary, brute force, or hybrid if you had an extremely poorly configured system, or if you had access to breached passwords. Okay. These are not really feasible to do on an active system. Does that make sense? Because you're going to get locked out almost immediately. All right. So some more password attacks. Okay, you got credential surfing. Okay. As the name would imply, what you're doing is you have someone's password that was breached in something. All right. So imagine just for instance that you had a Kmart account. Okay, anyone have a Kmart account in here? Imagine you did. Okay, and imagine, let's not say Kmart. Okay, let's call it Jmart. Okay, that way I don't get myself in any trouble. So if you had a Jmart account and Jmart was breached, someone gets your credentials and then they use your username and password combination on other services. Okay, that's why people recommend against using the same username and password for everything. Does that make sense? Okay, birthday attacks has nothing to do with a birthday. All right, it gets its name from the fact that people have the same birthdays. Same thing we talked about hashing. All right, what do we call it when 2 different files produce the same hash? What do we call that? Starts with a C. Second letter is O. Kind of like a car crash, but a little bit different. Collision. Exactly right. So it is possible for 2 passwords to produce the same hash. All right. So to avoid that, what you want to use is you want to use, at minimum, 256-bit hashing. Okay. You can also, of course, use something like SHA-512 if you wanted. That's certainly another option. For stuff like passwords, it's probably worth the computational use to do it. Okay, so that's, of course, going to be SHA-2 and SHA-3, respectively. All right. Why don't we want to use SHA-1? It's incredibly weak, is it not? Okay. In fact, SHA-1 you don't even use for certificates anymore. All right. I think this is pronounced Mimikatz. I might be wrong about that. I probably am, actually. But anyway, it's basically a tool that some guy wrote to steal Windows passwords. It's got a lot of different ways it can do it. But generally speaking, it's going to be looking for where they're stored in the short term. All right. So how do we mitigate against all this? It does no good to just say what the threats are if we don't know how to do anything about them, you know? Because if you don't know how to do anything about it, you might as well stick your head in the sand. Is that fair to say? So start with a strong password policy. Make sure your passwords have reasonable length requirements, possibly reasonable complexity as well. Okay, but in general, I personally tend to think that length is more important than complexity. All right. And that's based on a lot of different things, is it not? Okay, because as we think about what makes a strong password, look at the dictionaries. Okay, I don't mean look at a Webster's. Like I'm talking about look at the dictionaries that, you know, various attackers use. Okay, they have very somewhat complex passwords in because that's what the requirements are for most places. But to crack 15 characters, any random word combination, it takes a lot more time than to crack 8 characters of a commonly used password. Does that make sense? Have account lockout controls. This is vital. All right. So you don't ever want to have a system where people can continually try various passwords. If you're using Linux and you put in the wrong password, okay, it takes a long time to tell you. Okay, a couple seconds minimum usually. It's not because it's verifying that it's the wrong password. That's by design. Okay, because that way you can't gain any insight in timing the precise amount of time. Okay, because let's face it, if you could gain a little bit of insight into that. Now, is that something I would know how to do off the top of my head? Of course not. Okay, but there are definitely people who would know how to do that. Okay, stuff like fail to ban. Okay, fail to ban, of course, being something that's going to not allow you to continually try passwords. It's going to be a Linux thing that you can use. Okay, Windows has tools built in as well. All right, check your privilege. All right. So why do we want to check our privilege in the context of information security? Exactly. Okay, because I don't need to have access to everyone's social security number. All right. Someone does though, right? You think financial aid may need to have access to your social security number? How about the billing department? They probably do. I think payroll probably needs access to my social security number. But financial aid doesn't need to touch my social security number, do they? No legitimate reason why financial aid should be touching my social security number. I'm not a student here, okay? Therefore, I shouldn't be receiving any financial aid. All right, so check your privilege. Maintain strong security layers. Okay, this is across the organization. All right, don't ignore physical. As a security professional, the physical is your responsibility. All right, and don't ignore any of them, because if you have one weak layer, that's all it takes. If I can walk into your organization, stick a little flash drive in, I'm in. Am I not? If I can walk into your organization, abscond the PC, I'm in. Okay? Even more egregious, if I walk into your organization, straight up wheel the server racks out of your organization without anyone stopping me, yeah, I'm definitely in at that point. Is that fair to say? And then lastly, hash and salt passwords. Okay, this is going to be done by default in stuff like Active Directory. All right, and for most things, it's going to be pretty much ample. Okay, because Active Directory, we can integrate with pretty much anything that we're using as an organization. But if you had a system you're making yourself, that's where that would become something you needed to manually have it do. All right, Classwork. Get with your partner you've been working with all semester and make a role-based access control matrix for the company that you previously used. Okay, so we previously had companies in here, right? You guys remember them? Okay, so you're going to make an access control matrix. Look up examples online if you need to. And then I have a challenge here to use Linux notation. Okay, you don't have to do this, but you can if you want. All right, so take about 10 minutes and do that. Just make general roles, that sort of thing. and then the general systems that your company would use, just like we did up here. Write it on paper. We're going to present them briefly at the end of class. All right?